In this episode, we're going to take something that can feel like magic or chaos when you're new and turn it into a clear mental model you can trust. How teams coordinate changes when everyone is working on their own copy of the code. Git is the tool that makes this possible, but the part that confuses beginners is the remote side, because you can't see it sitting on your laptop. A remote is simply a shared place where the team's repository lives, and it acts like a meeting point where everyone can exchange updates. When your automation code is meant to be deployable, the repository is not just a storage spot. It is the record of what the team believes is safe to run. Remote Git commands are the actions you use to synchronize that record across people, time zones, and different work schedules, which is why understanding them is a practical skill, not a trivia topic. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The most important thing to understand first is that Git is not one single thing. It is two connected worlds, your local repository and one or more remote repositories. Your local repository is the full history and current state of your work on your own machine, and it can keep going even if you have no internet connection. The remote repository is another full copy of the history, usually hosted on a server, and it is the shared reference point that others can access. Coordinating with a team means keeping those two worlds aligned enough that everyone is building on a consistent foundation. Remote Git commands are not about writing code faster. They are about reducing confusion and preventing accidental overwrites. If your automation breaks at runtime, a common root cause is mismatched expectations about what code version is actually being deployed, so remote coordination is directly connected to operational reliability. One remote concept that beginners often miss is that a remote is not a person and it is not a branch. It is a named connection to another repository. When you hear someone say origin, they usually mean the default remote name that points to the main shared repository. That name is not special in a technical sense. It is just a convention that Git sets up for you. This matters because you might have multiple remotes, such as one for the official team repository and another for a personal copy or a training mirror. Remote commands always act through those connections, and the clarity comes from knowing which remote you are talking to at any moment. In distributed teams, confusion about the remote target is one of the fastest ways to create coordination mistakes, like pushing code to the wrong place or pulling changes you did not intend to trust. Fetching is the remote action that gives you visibility without changing your local work directly, and it is one of the safest coordination habits. When you fetch, you ask Git to contact the remote, download new commits and updated branch pointers, and store them in your local repository as remote tracking references. A remote tracking reference is like a bookmark that says, this is where the remote branch was the last time you checked. The key is that fetching does not automatically merge those changes into your current work, which means you can see what's new before you integrate it. For beginners, this is a huge mental relief because it separates the act of learning what changed from the act of applying those changes. In a team setting, fetch is a way to stay aware of ongoing work without constantly reshaping your own working state. Pulling is fetching plus integration, and that second part is where surprises happen. When you pull, Git contacts the remote to get updates, and then tries to combine those updates with your current branch. If your local work and the remote work touched similar areas, Git may need help deciding how to combine them, which is where merge conflicts appear. Beginners often think pull just means download, but it is more like download and attempt to reconcile. This is why many experienced people prefer to fetch first, review what changed, and then decide how and when to integrate. In automation code, small differences can have big effects, so blind integration is risky, especially when you are coordinating across distributed teams where people may be changing nearby files at the same time. Understanding pull as a compound action helps you choose safer habits. Pushing is the opposite direction. It takes commits you have created locally and sends them to the remote so others can see and use them. A beginner mistake is assuming that saving a file or committing locally means the team can see it, but commits live only in your local repository until you push them. Push is not just about sharing. It is also about creating a stable, reviewable point, and a shared history. In many teams, deployment automation and build pipelines are triggered by remote updates, which means pushing can be the moment your code starts affecting real systems. That connection is why teams often adopt rules around when and how you push, and why you should treat push as a deliberate act. If you push broken changes to a shared branch, you can interrupt other people's work and potentially disrupt automation delivery. There is also an important idea behind the scenes called tracking, which is how your local branch knows which remote branch it is associated with. When a branch tracks a remote branch, Git can tell you whether you are ahead or behind and can simplify commands by assuming default targets. This convenience is helpful, but it can also hide complexity if you do not know what is being assumed. In distributed teams, you want to be confident that when you fetch, pull, or push, you are interacting with the correct branch on the correct remote. Tracking makes common workflows smoother, but the clean beginner approach is to understand that this is a relationship, not a guarantee. If you create new branches, switch remotes, or rename branches, that relationship can change, and it's your job to notice when the assumptions no longer match reality. Another remote coordination concept is that remote repositories can enforce rules that your local repository cannot. For example, a remote might require reviews before changes are accepted into certain branches, or it might block pushes that would rewrite shared history. You do not need to memorize policy options to benefit from the concept. The important beginner takeaway is that the remote is often the place where the team encodes safety practices because it is the shared choke point. That is especially relevant for deployable automation because you want consistent safeguards that apply to everyone, not just to whoever happens to be careful. When remote rules exist, they are not there to slow you down. They are there to make sure the shared history remains trustworthy. Trustworthy shared history is what allows automated build and deploy systems to operate without constant human babysitting. Distributed teams also need a way to share not just final code, but in-progress coordination signals, and remote branches are a big part of that. When someone pushes a branch to the remote, it becomes visible to others, which supports collaboration, review, and early detection of conflicts. This is different from pushing directly to a shared main branch, because a branch can represent a safe sandbox for integration discussions. Even if you are not thinking about formal review processes yet, the concept still matters. Pushing a branch is a communication act. It says, here is a coherent set of changes that someone else can fetch, examine, and test. In automation work, that can mean someone else can validate that your changes do not break deployability before they are merged into the path that production uses. It is also useful to understand that remote coordination is about time, not just people. In a distributed team, you might start your day with code that is already several hours out of date because others committed overnight. If you build new changes on top of outdated assumptions, you can create larger conflicts later. This is why teams often develop a rhythm of syncing early and often, especially before starting new work and before pushing. The goal is not constant disruption. It is small, manageable integration points. In automation projects, small integration steps reduce the chance that you will discover a breaking change only after it reaches a critical environment. Remote commands make that rhythm possible because they let you cheaply check and incorporate progress from the rest of the team. When coordination goes wrong, it often shows up as someone saying, I have the latest, when they really mean they have the latest they pulled, not the latest that exists remotely. Fetching and checking remote tracking references helps you avoid this subtle mistake. It also helps to recognize that the remote can move forward even while you are working, so your local view is a snapshot in time. That is not a flaw. It is how distributed systems work. The discipline comes from updating your snapshot at the right moments so your decisions are based on current information. In practical terms, this reduces duplicate work, reduces merge pain, and reduces the risk of deploying something built on stale assumptions. When you think about the remote as the team's current truth, remote commands become a way to stay aligned with that truth. Another coordination habit is understanding what it means when a push is rejected. This can happen when the remote branch has moved forward and your local branch is behind, which is Git's way of preventing you from accidentally discarding someone else's work. For beginners, a rejected push can feel like Git is being hostile, but it is actually Git being protective. The right reaction is to sync with the remote, integrate changes, and then try again, rather than trying to force your version through. This mindset is important in automation because forceful rewrites of shared history can confuse build systems, break deployment references, and make incident response harder. A shared repository is a shared memory, and rewriting memory without coordination is how teams lose context. Remote Git commands are designed to coordinate memory updates safely. The biggest payoff of understanding remote Git commands is that you stop treating teamwork as a special case and start treating it as the default operating mode. Deployable automation is rarely a solo artifact forever, because even if you start alone, you eventually need review, maintenance, and updates. Remote commands let you work independently without drifting away from the team, and they let the team move forward without waiting on one person. That independence plus coordination is the real value of distributed version control. When you can fetch to see changes, pull to integrate them thoughtfully, and push to share your work responsibly, you create a workflow where automation changes are visible, auditable, and predictable. That predictability is what keeps automation deployable as teams and systems grow.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.